Hi, welcome back to another episode of Algebra in Words, the video series. In this episode, we're going to be looking at compound inequalities. And in this video, this is what we're going to go over. We're going to be looking at inequality symbols, including the inclusive versus the non-inclusive type. We're going to be looking at the difference between and versus or, and I'll get into that in a minute. We're going to be looking at graphing inequalities, both simple and compound. I'll explain the two of those. We're also going to do a review of simple inequalities. Then we're going to look at notation, which is the way that you write or report inequalities. And there's two types. There's interval and what's known as set builder. We'll look at both of those. Then we're also going to look at converting an inequality into interval notation. Also, by the end of this video, we're going to learn how to do solving and graphing compound inequalities. And the last thing that we'll do is I'll show you how to solve a three-part inequality. And by the end of this video, this should all make sense. So I'm going to pause this, and I'm going to erase the board, and we're going to get started on some of the topics above. Okay, I put two simple inequalities on the board. The first one is 2x plus 1 is less than 3. And I highlighted that, I'll get back to that shortly, x minus 1 is greater than or equal to negative 5. Let's first start with the symbols. These are the four inequality symbols. You always read it from left to right. And the closed side we would read as less than, greater than. Then this one would be less than or equal to because it's got the bar on the bottom. And this would be greater than or equal to because it has the bar on the bottom. Where I say inclusive and non-inclusive has to do with these symbols. The ones that do not have the bar underneath, we call them non-inclusive. And when we graph them in a second, I'll explain that a little bit further. But that basically means that the value of x the values of x that it's referring to do not include the specific number. However, these symbols that do have the bar on the bottom, we call them inclusive because since they're less than or equal to or greater than or equal to, the equal to means that it could also equal or be inclusive of that number that it's referring to. We'll get into that. It'll make a little more sense when we graph in a second. Now, the next thing is inclusive and non-inclusive is going to play a role when we graph. I'll explain that in a second. So as I said before, this is going to be a brief review of simple inequalities. But let's talk about what is a compound inequality. Well, a compound inequality is just a number of simple inequalities basically on the same graph or on the same number line. And the way that you would report the domain or the set of values that the compound inequality equals would depend on whether it's an and or an or, which again, I'll get to shortly. But what I want to do now is let's solve this simple inequality and then graph the simple inequality. We'll do it for this one and then this one. And I chose this because this one is a non-inclusive and this one is an inclusive inequality. Before we start that, one quick note. The difference between inequalities and equations is that in equations, the left side equals the right side. But in these are mathematical sentences or statements in which the left side does not equal the right side, but it is defined by certain values using the inequalities. So, how do you solve a simple inequality? Well, it's easy. You do it the same way virtually that you would for a regular equation. And I'll explain the one difference. But in summary, you're going to solve for x, meaning make it so that one side has x isolated and everything else on the other side. The one difference between solving an equation for x and an inequality for x is that if and when you divide or multiply both sides by a negative number, you have to reverse the direction of the inequality symbol. Hopefully, if one of these examples has that, I'll be able to highlight that. So let's solve the simple inequality. And first we're going to isolate the term with the variable. We're going to subtract 1 from both sides. And keep in mind, so when you're subtracting 1 from both sides, you do not change the symbol. Only when you multiply or divide both sides by a negative number. So this will leave us with 2x is less than 2. And now let's divide both sides by 2. And we get x is less than 2. Okay, so we just solved the first simple inequality. Now let's look at the next one. And again, the goal is to isolate x and get everything else on the other side. So we're going to add 1 to both sides. That's going to give us x is greater than or equal to, negative 5 plus 1 is negative 4. So now we have 2 simple inequalities. And what we're going to do next is we're going to graph them. Just to give myself a little more room, I think I'm going to move this over a little bit. Okay, and I just realized I may have misspoke, but 2 over 2 is 1. So this will be x is less than 1. So now we're going to graph this one, and it's going to look like this. This is a review of how to graph a simple inequality. Start by setting up a basic number line like this. A horizontal line, and always remember the smaller side, or negative infinity, is approached on the left, and on the right approaches the greater side, or infinity. And since we only have one number here, we're going to put 1 here, and I'm putting that kind of shifted to the right for a reason, because we're going to compare it to this graph in a second. And now, since this is x then is less than 1, we're going to indicate this by drawing an arrow like this towards the left to show that all the possible values for x defined by this inequality would be 1 and anything less than 1. Now is the time where we have to look at the inclusiveness or non-inclusiveness of the symbol. And this is a non-inclusive symbol. There's 2 ways to indicate that on the graph. One way is by showing an open circle like that. And another way is, I'm just going to write it above. Another way is to show it with what we think of as a parenthesis that's open towards the direction that the values of x are meant to count for. So those are 2 ways, and this is for non-inclusive symbols. Now let's graph this one, and I'm going to do them one over top of each other. So now let's draw another number line. Remember, the smallest side is on the left, the higher side is on the right, and x is greater than or equal to negative 4. So since we had 1 here, I'm going to draw negative 4 to show that it's smaller than 1 to the left of the 1. And now how are we going to graph it? Well, since now we know that all the values for x are greater than or equal to negative 4, we could either draw the symbol with a closed dot. Closed dot means inclusive because it's an inclusive symbol, meaning the values could include negative 4. So I'm going to indicate that with a closed dot like that. Or if we wanted to draw it with the other symbol, I'm going to do that here. Negative 4. The other way to draw a an inclusive symbol is by using an open bracket that's open towards the direction of the values. So in that case, we're going to draw an open bracket open to the right to indicate that the values for x for this simple inequality include negative 4 and everything greater than negative 4. Okay, so there's our little review on simple inequalities. But now we're going to continue on, and we're going to talk about and versus or. I'll get into and versus or in a little bit, but what we're going to do first is we're going to use this. Okay, so now this simple inequality and this simple inequality connected by the word and, this whole thing would make up a complex inequality, and that's what we're going to solve next. So the first thing that we can do is actually pretty easy. And I'm going to erase 2 of these for a little room. and this would have been 1, and this one is -4. And what we're going to do is now combine these on the same graph, the same number line, using AND. I will go into AND and intersection in a minute, but for now, let's just kind of apply it, and I'll explain it more in a minute. AND means only the values that overlap from one inequality to the other, okay? And so here's what we're going to do, and just for clarity, I'm just going to show both of the inequality graphs with a line because it'll make it a little more obvious where they overlap. So if the values of this go in this direction, and the values of the bottom one go in this direction, then I have a line in between, and since this is AND, we're going to indicate only the points and places on each of the number lines where they overlap. So let's start left to right, and if we look at the left, we could put a bracket here at -4, and as we move to the right, we're going to put a parenthesis here from the top one from x is less than 1. And now the values only which overlap from this line, number line, and this number line would be in between them. So graphically, now I'm going to erase this one, and well, actually I'm going to leave it here, but there's two ways that we could now answer the complex inequality. One way is if they asked us to graph, this is the answer, and we would want to clearly define and label it. So we would have the bracket open to the right, we would have the parenthesis open to the left, the bracket is at -1, and the open parenthesis is at 1. So this would be the answer if we were asked to graph it. So I'm going to circle that. Okay, and you would want the -4 here and the 1 here, but I don't have that much room. Let me squeeze it in here, the 1 and the -4. Okay, and now suppose that we wanted to report the answer in interval notation. Okay, and watch how easy this is. We're going to take this and this, but we're going to put the numbers inside. So watch how this converts from here to -4, comma, and the higher limit on the right, which is 1, with an open parenthesis to the right of it. Okay, so take a minute and notice how the number line converts into interval notation reporting. Okay, and there's also another way that we can report the answer, which is to report it basically in inequality format. So it's basically a way of combining this simple inequality with this simple inequality. And I'm just going to erase a little bit so we have more room. Okay, so watch how we combine this simple inequality with this simple inequality into one compound inequality sentence. What we're going to do is make sure that the smallest value starts on the left. That would be the -4. So think of taking this simple inequality and just flipping it so that the -4 is on the left, like this, -4. And since we flipped it, what started as greater than or equal to when you read from left to right is now going to look like this, less than or equal to x. So again, notice how we just took this and flipped it so that we could get the number, the lowest number on the left. But now we're going to combine what's here over here. And since we already have x on the left, and 1 is the greater number compared to -4, we're going to do this. And this is the compound inequality format of the answer when we combine the simple inequalities by AND. So actually, this is the graphical answer. This is the interval notation answer. And this is the compound inequality answer. All right, and that actually summarizes a lot. You should be able to do many problems where you're given something like this and report it in any of these three formats. So I'm going to pause the video and we're going to then look at and versus or. I erased a little bit and just moved some things over so we had some room. I just put this simple inequality here, this simple inequality here, and the answer from the and compound inequality here, the graphical answer here, and the interval answer here. And we're going to compare that to doing the same problem, except in this case, we're going to look at it in the case of or. Before we actually solve the or compound inequality, I told you that we were going to talk more about and versus or. So let's talk a little bit more about that and just take a minute. What you need to know is the relationship of and. So first of all, what does and mean? And you should only think of the values that are in common or overlap. You could also think of it as where they intersect. And intersection is a key word because that's the word for this symbol, which looks like an upside down U. The upside down U is the symbol for intersection, which is really interchangeable with and. Sometimes you'll use this symbol to report an answer. Sometimes you'll see this in a problem that is showing combining or and of two inequalities. Okay, and that contrasts with what's known as or. Now normally we might think of or as like either or, but the way that you should think about or in this context is, I like to tell you to think of it as both or all. Okay, now what I need you to do is compare to and. And means only where they intersect. But or means all the values, whether they intersect or not. It has nothing to do with whether or not they intersect. They might, but they don't have to. So basically, when you report a compound inequality that is or, you're taking all of the values of either of all the simple inequalities and their graphs, no matter what. Okay, you're combining them. Or, the symbol for or looks like U. So you'll see that symbol in the book. And coincidentally, I don't think it's literal, but coincidentally, the U stands for union, meaning all values in union together. So now let's take these original inequalities that we solved for and apply it as if the problem said or, and then we'll compare the answers. So I rewrote the graphs of the simple inequalities. This one is for x is less than 1. Notice the parenthesis, non-inclusive. And this one is for x is greater than or equal to -4. Notice the open bracket to the right. Okay, so in the last one where we use this to show only where they intersect, take a second and look by the red lines. And what you want to think of is to show where all of the red lines would show on this graph if we were to combine this and this. Okay, think of if you're just like adding these two lines together. And basically it would look like this. It would be all of the values. So there's the way that you would indicate this is let's show it as interval notation. And the way that we would show it is starting on the lowest value on the left, which would be negative infinity. So we would draw negative infinity like this. And whenever we have negative infinity, we always give that a parenthesis because we call that non-inclusive because we're saying that the values of x approach negative infinity in this case, but never touch negative infinity. So long story short, we're going to put a parenthesis by that, comma, and then looking at this, what's the highest possible value of x? It's infinity. So we're going to put positive infinity on the right, and again, a closed parenthesis. So in summary, when we used or for both this simple inequality and this one, and we took each of their graphs and sort of combined them or added them or made a union of them, right, combined them, it happened to be that it accounts for all possible values of x. And therefore, we can show the interval notation like this. And another way that we can show it is, if we were showing it as a compound inequality, we could actually show it like this. Negative infinity is less than x, which is less than infinity. And that basically summarizes it because this includes all possible values. So thanks for watching. I'm going to end the video here, but in the next video, we're going to look at problem solving using these principles.